Miniature steam hacks, hints and tips. This episode is all about model steam engine cylinder lubricators, mainly the mechanical type. These lubricators work in a very simple way. There's a central ratchet and two pawls, one on the arm and one on the body of the lubricator. And with this arrangement, the shaft can only rotate in one direction, which is what we need it to do. And with the arm removed and turned round, you can see the pawl on the arm itself. This lubricator is called a ratchet type lubricator for obvious reasons. It has a ratchet, and this ratchet shaft is very loose, which is one of the reasons I think it doesn't work properly. This is a very common type of mechanical lubricator, but there are other types. There are lubricators with very similar internal mechanics to this one, but using a one-way clutch instead of a ratchet. There are also some types which use an eccentric on the shaft that depresses a spring-loaded pump piston. The part that I'm currently removing is a very important part of the lubricator. This is a clack valve or one-way valve. It has a stainless steel ball inside it with a spring to hold it in place. Without this, nothing will happen and steam would blow back into the lubricator. It is also very important to have a second non-return valve where the oil goes into the cylinder. As I move all the pieces out of the way, you can now see the little oscillating cylinder. Quite a nice piece of model engineering really, a model in its own right. The main shaft is threaded into the crank web. If you put it in reverse it will unscrew itself, but you can clearly see the little piston going up and down in the cylinder. The one flaw with this design is that the oil flow is non-adjustable, unless you put some sort of a bypass valve in, which is very fiddly. The spring-loaded piston type are usually internally adjustable for oil flow, but with this type you have to limit the travel of the arm. These kind of pumps are generally driven off a valve rod and sometimes with a reduction linkage. For each revolution of the crankshaft, the ratchet needs to be clicked over just by one notch. Any more than that and the lubricator will over-oil the cylinder. The complexity of mechanical lubricators often put people off, but they really are technically better than a displacement lubricator shown here. On the plus side, a displacement lubricator is a fit-and-forget device, and once you get used to how far to turn the little wheel to regulate the oil supply, they can be very reliable. But on the downside, you never really know how much oil you've got left in the lubricator. Mechanical lubricators are fine if they're working okay. If using a ratchet-type mechanical lubricator, I would always recommend taking the time to make sure there's not too much arm travel. It's not a massive problem if you overoil your engine, but it is if you sat behind a steam locomotive getting a face full of oil, not to mention the cost of the extra oil. Instead of rotating evenly, it's just dithering about in one spot, and if this happens, it means that the cylinder is not receiving lubrication. Without touching it, it starts off again. But I don't really want this. I mean, look at it, it just looks stupid wobbling about. It's a non-lubricator. While I think on, I'll put some oil in the lubricator because that's getting quite low as well. Mechanical lubricators on steam engines can be problematic. It's well known that they're not always the most reliable device out there. But generally speaking, once you get them to work okay, they just carry on working. But this one's not doing its thing at all. In this clip you can see one solution. I've moved the position of the link from the eccentric a bit higher up on the arm on the lubricator. In this clip I'm removing the driving pin because I need to drill another hole in the arm that drives the lubricator. And in order to do this I have to remove this small handle. Once I undid the lock nut it just wound off the shaft. The reason for taking this part off is because I need to remove the arm completely to take it over to the drilling machine. In no time at all, I drilled and threaded another hole in between the two existing holes. So here I've refitted the main driving arm and let's see what happens. And it's still dithering about a little bit, not as bad as before, but it's still a little bit erratic. I think possibly the ratchet pawl underneath needs a stronger spring, but then if I put a stronger spring on the ratchet pawl, it's going to wear the ratchet and itself more than it would do if it didn't have such a strong spring. Oh, and by the way, the word is pawl, P-A-W-L. I've put the spelling on screen so there can be no confusion. And the position of this ratchet pawl is just to the left of the R in ratchet pawl. I decided in the end to fit the driving pin in the top hole of the lubricator drive arm, and now the movement is much more consistent. On this type of lubricator, the amount of oil that gets pumped out per revolution can be altered by the large nut on the right hand side of the lubricator. So if I find that the lubricator is delivering too much oil, I can adjust this nut to control exactly the amount of oil that I need to be delivered to the cylinder with every revolution of the pump. And that's it. I'll just leave the engine running in slow motion till the end of the video. Thanks for watching, and I hope you found it useful. Click on the section of the website that says Video Playlists, and by doing that you will find it very easy to find other videos that you may like to watch.